Okay, the following is a video over 2-1 notes, and this is inductive reasoning and conjecture. I want to talk about what the word inductive reasoning is, and this is using numbers and facts to draw conclusions. Okay, and then the conjecture is the concluding statement. Concluding statement. All right, so there's, it's basically what you're trying to do using numbers and facts to draw conclusions. You're just, in my opinion, you're following patterns. Okay, and this is, guys, I do this for a living. Okay, I'm pretty good at this by this point. Not only do I follow patterns with mathematics and algebra, but I do it with concepts and I do it with situations. Okay. So one of the big things that I've noticed is the flipped classroom. Okay, the flipped classroom. What I've noticed uh, with the flipped classroom, the pattern that I see, the pattern is that if students, um, well, the pattern is kind of also my conclusion. So if students watch the videos at home, okay, um, and they start their homework. So if they watch videos at home and start their homework, then I notice that in those students understand the concepts much better than students that don't watch the videos. Okay, understand the concepts much better. Okay, much better than if I just taught. Okay, that's kind of like a pattern that I notice. So, guys, when I teach, I think about, okay, what went well, what didn't go well. There are things that I notice. There are patterns that I notice. And so that's one of the reasons why I like the flipped classroom so much, is because it forces you guys to actually try. Instead of me just showing you how to do everything, you guys are the ones sitting down and doing the homework, and I think you guys are getting a lot out of it. Okay, much more so than if I just taught you in class. Okay, so um, I've just seen, I have noticed a pattern of better work coming out of all students that are in the flipped classroom. If I just teach in front of the classroom, then not everyone's going to get it. But if you guys take your time and you watch the videos and you do what I ask, it works a lot better. Now, the first thing is that you actually have to watch the videos at home, okay, and start the homework, okay? If you don't do that, then it doesn't work, okay? But that's the pattern, okay? And so the pattern that I see is that, kids do a lot better. So this is, a pattern that leads to a concluding statement that the flipped classroom is a good way of educating, okay, and learning. All right. So let's kind of take a look and do a couple of examples and kind of show you what I mean about this. Um, and so what I want to do is I want to write a conjecture that describes the pattern in the sequence. Then use your conjecture to find the next item in the sequence. So what I see here is that this is my first part of my sequence, this is the second part of my sequence, and this is the third part. Okay, we want to go, and the conjecture that I'm making is I'm asking myself the question: what is changing from this step to this step to this step? What's happening each time I go to another step? Step one, two, and three. Okay, so what I see here is I have this diamond shape block with two two light and two dark blocks inside of it. Okay. Now what I also see is I see that same block here. Okay. And then I've added two dark and one light. Okay. And I'm gonna look at the same thing here. I have that original piece, and I've added the two dark and one light, and then another two dark and one light. Okay. So my conjecture is that in each step we add two dark blocks and one light block. Okay, so let's draw the fourth term in the sequence. Okay, let's do that. So I'm going to have my original, pardon my drawing, may not be great. Alright, but I've got two dark, one light. I'm going to continue on with that and draw another. Oh god, this is just terrible. Okay, I'm going to draw another one. Alright, you can kind of see it, I hope. My apologies about my drawing. Not the best, but I try my best. Okay. So basically what I would do on the fourth one is I would just add another one of these. Your fourth one would look, there, that one's better. It's going to look like that. Okay. So that's the idea. Okay, in this one, in number 2, what I've got going on is that I've got the sequence of numbers, and I go from -4, -1 to 2 to 5 to 8. Okay, so this is my first term, my second term, my third term, fourth term, my fifth term. What's going on in my sixth term? Okay. Now, what I'm noticing here, I notice a pattern. I notice that for every time we move up, we add 3. Okay, that's the pattern that I see. So I'm going to add 3 to everything and add 3. Okay, so my next one I'm going to add 3. Okay, so we're actually going to get 11. That's my answer. Okay, but my conjecture is that each term, each new term, let me write that, each new term is 3 more than the previous term to you. Okay, so that's it. All right, you're just noticing a pattern, writing a conjecture. Okay, what's happening here? Okay, you follow a pattern, and then you just state pretty much what the pattern is. Okay, and then continue on that pattern. All right, so let's take a look at these in 3 and 4, and this is make a conjecture about each value or geometric relationship. Okay, so it says points A, B, and C are collinear, and then it says D is between B and C. So what I want to do is make a conjecture. Okay, I want to draw a conclusion. Okay, that's what it wants me to do. Draw a conclusion about the statement. All right, and guys, this could be, you know, a statement in words. I'm thinking more of like a picture. Okay, draw a picture and then make a conclusion. Draw a conclusion based off a picture. Okay, so here's what I've got. Okay, it says this. It says points A, B, and C are collinear. Okay, so I'm going to draw a line. Okay, when it says something are collinear, that means that things are on the same line. So here's what I've got. Okay, I've got points A, B, and C are collinear. Okay, so those are on the same line if it allows me to draw a picture. And then I'm interested in the statement here that says D is between B and C. So because B and C are collinear and it says that D is between B and C, I can draw a point in here in between B and C and call it D. Okay? Now, what conclusion can I draw about this? Okay. And there's a number of things we can say, but the first thing I want to say is just using B, D, and C. And I'm going to write this. I know because those are on the same line that this follows the segment addition postulate. And I can say that BD plus DC is equal to BC. Okay? So guys, I'm given a piece of information. I'm drawing a conclusion. I'm drawing a picture and I'm going, I'm asking myself the question, what do I know about the picture? Okay, and that's it. And I can draw this conclusion based off of what we've previously learned. Okay. Okay, let's take a look at number 4. It says point P is the midpoint of NQ. Okay. So here's what I've got. Let me draw another line segment NQ. All right, with endpoints of N and Q. Okay, and then it says that P is the midpoint. Okay, so I'm over here in the middle, the very, very middle piece is the point P. Okay, and so if P is the midpoint of NQ, then what does a midpoint do? A midpoint is the middle point. It actually cuts a segment in half. Okay, and when it cuts it in half, that means I'm getting two congruent pieces. Okay, so I'm going to call this congruent to this. So then the statement that I can draw, the conclusion that I can draw is that NP is congruent to PQ. And guys, we've been doing this. Okay, I've already told you this. Okay, we've gone over this in class. This piece of information, just reading this, allows me to draw a conclusion based off of what I know, based on the definition of what a midpoint is. Okay, so that's all we're doing. We're just drawing conclusions based on what we got. All right, let's take a look at determine whether each conjecture is true or false. Give a counterexample or any false conjecture. Okay, so a counterexample, if it's false, okay, if it's true, it's true. If it's false, a counterexample is something that proves to be false. Okay, so it's an example. Okay, it's an example that disproves your conjecture. Okay, so here's what we've got. It says if AB, BC, and AC are congruent, then AB and C are collinear. Okay, so then, and what this means is that is this statement true for all of this? Okay, is there anything that could disprove this? Okay, and so let me draw an example of how this could work. Actually, I think let's see if it does. I'm not even sure if it does. I'm gonna put 3 points down. No, I can't do it on a line. If this is A and B, if that's congruent to B and C, okay, then AC is the sum of these two, so that wouldn't work. Okay, so this is no. Okay, this is an example of how it wouldn't be. But the problem is that I haven't identified that AC is congruent. Okay, so this is no, this is false. All right, but let's come up with a reason why. Let me show you that I can have these 3 segments be congruent and they won't be collinear. This is when they're trying to be collinear, and it doesn't work. Okay, AB is congruent to BC, but AC is not congruent to the other two. But if I had this, let's say I had a right triangle, or not a right triangle, an equilateral triangle. Okay, and I call this A, B, and C. Okay, AB is congruent to BC, which is congruent to AC. Okay, I can make this statement that 3 segments are congruent. But the question is, are they collinear? And this is not collinear. Okay. All right, we can make the statement that those segments are congruent, but they can't be collinear. Okay, so this is a false statement. Okay, and then it says this. If AB plus BC is equal to AC, then AB is equal to BC. So that follows what we have up here. Okay, and you could make this true. Okay, this is true if I have this picture, but is it true for all of them is the question. And the answer is no. Okay, and so what I can do is this. I can call this A, right here. I can call this C here, but I could put B right here. Okay? And I could call this 5, I could call this 2, and I could call the whole thing 7. Okay? And so here's the thing, guys. I know that this is true. Okay? 5 plus 2 is equal to 7. But the question is 5 equal to 2? Okay? Is AB congruent to BC? And the answer is no. Okay, this doesn't work. 5 is not equal to 2. That's false. Okay, and so this whole thing, guys, is my counterexample. Okay, I'm trying to draw a picture to see whether this could hold or not. Okay, so a lot of times, you guys may say something and I'll be like, well, I will give you a counterexample to disprove you. And you guys do the same thing for me. Okay, it's something that we do to prove a point. A lot of people use this in their jobs. A lot of lawyers use this. A lot of cops use this. Their whole thing is based off of patterns and facts. Okay, their whole thing, let's say you're, brought up on charges for a crime. A cop is going to sit you down and they're going to try and use what you say and use a counterexample to disprove what you're saying if you're lying. Okay, if you're lying, there's no counterexample to be made for you to be if you're not lying, then there's no counterexample to be made because what you're saying is true. But what you're saying is false. That's what they try and do. They try and get some evidence on you. They try and give it a counterexample to prove that you're wrong. Okay, so you guys do this stuff all the time. When we catch you, you know, taking 30 minutes to go to the bathroom and we notice that you're walking around the halls, okay, that's a pretty good, what you're saying is false, and I'm giving you a counterexample. Well, it doesn't take you 30 minutes to, maybe it takes you 30 minutes to go to the bathroom, but isn't, but that does not include you walking around the halls. So that's all I got for 2-1 notes. So good luck with this, and please get started on the homework.